Hey there, TouchDesigner developers. Jack DeLaura here with the Interactive and Immersive HQ. In this video, we're going to have a look at porting GLSL effects to TouchDesigner. So we're going to take this really cool interactive effect from Shader Toy, coded in GLSL by Dave Hoskins, and adapt it for use in TouchDesigner. So we're going to go through the kind of considerations that we need to make given that this has some mouse interaction, along with the various things we have to do to adapt the code to run in TouchDesigner. And we'll also look at ways that we can customize things a little bit and add easy ways for us to make changes using TouchDesigner's built-in operators and parameters. So we'll start off by making a kind of plan of attack and then get into the nitty-gritty of coding. So let's have a look at the Shader Toy example to figure out what considerations we need to make for adapting this to work in TouchDesigner. First of all, we've got more than one shader being utilized for this particular effect. You can see up here we have a number of tabs of each containing their own separate code. And the image tab is what produces the final output that we see on the left. The buffer A code is what takes the mouse input and then does some math and generates some data that is used to create these kind of interesting rotations of all these cubes. And then we have a common tab, which has just one line of code, which defines a sort of global variable that is related to the size of these cubes that is then accessed by buffer A and the image code. Another thing that we need to consider here is the inputs that are provided to each one of these shaders. So we've got this image shader here, which has at the bottom here, we've got four possible inputs that we can provide to the shader. We can see here we only have one used in this particular situation. And that, if we click on it, is the output of buffer A. So this is a pretty simple situation here. We're just taking the output of one thing and plugging it into the input of image. For buffer A, we'll notice that we also have iChannel 0 defined, and it is once again the output of buffer A. So in this particular situation, we're actually taking the output of this buffer and then running it back into the input, creating a feedback loop. So as soon as we think feedback loop, that is going to cue us into the fact that we're going to need a feedback top in TouchDesigner. Another thing that we want to consider here is that we have mouse interaction. So we're tracking the XY position of our mouse. We're also tracking whether or not we have clicked the left mouse button down. There are a number of other differences in the code itself that we'll have to pay attention to, but this will give us an idea at this point, at least, how we can start to structure the shader code. So what we're going to do now is to create a simple diagram just to kind of map out visually how this will look in TouchDesigner. So if we consider these boxes as our operators in TouchDesigner, these are going to be GLSL tops, and we'll have one for our buffer A code, which again is doing some math based on our mouse position. And then we're going to have our image code in a separate GLSL top. As we just discussed, the output of buffer A is going to be connected to the input of image. And then image will be sent, I guess we can add another node here. This will be like our output to screen. The output of image is going to be sent to our screen. And then as we just discussed, based on the fact that the buffer A output is also being run into the input of buffer A, creating a feedback loop, we're going to need a feedback operator in terms of TouchDesigner in order to accomplish that. So in that case, we're going to need, let me see if I can get this connected in a way that makes sense. So we're taking the output from buffer A, running it into the feedback operator, and then running that into the input of buffer A. So this is how the general architecture of our network will be set up in TouchDesigner. We're also going to have basically a transparent constant operator at the beginning of our network just to provide the general attributes like the resolution of the texture, etc., to initialize this loop at the beginning. And then another thing that we'll have to consider, which we'll look at in the program itself, is how we're going to deal with the mouse interaction. Hopefully this gives you a better idea of how we can start to take the code that we see in ShaderToy, or in any platform for that matter, and start to adapt it for use in TouchDesigner. We really need to pay attention to the different shaders that are working together to provide the output, the inputs, and the outputs of each one of those shaders, as well as the types of interaction that we want to have in our final effect. All right, so over in TouchDesigner, we're going to start off by adding in the two GLSL operators that we were just talking about. The first one is going to be for recreating buffer A. So I'm going to rename that to buffer A, hit enter. You'll get this little dialog, which we're going to hit yes to all on. We're then going to add in an additional GLSL top, and this is going to be for our image output. So I'm going to do image, there, and again, hit yes to all. So we've got our two GLSL operators, which have each a pixel shader, which will be where we actually do our GLSL coding. But before we get on to the code portion of this project, let's go ahead and make some connections and kind of finish the top portion of the network so that we have everything kind of in place for our code. So first of all, we know with just these two operators that we need a connection from the output of buffer A to the input of our image code or shader. And so I'm going to connect the output rather from buffer A to the first input of the GLSL image top. Now, let's take a look at the inputs for buffer A. Now, remember, this is where we're going to need a feedback loop. And so that means we're going to need a feedback top. The feedback top also needs something connected to its input to provide the initial texture for the loop. And so I'm going to start off with a constant top, which I'll just set the alpha here to 0. So we've got a transparent texture here. And then we're going to add the feedback top directly afterwards. I'll kind of move these back a little bit. The output of the feedback top is going to be connected to the first input of our GLSL buffer A operator. Now, in order for the feedback to be generated, it does need to have a target top provided, and that is going to be our GLSL buffer A operator. So I'm going to drag that onto the target top parameter, and now we've got a feedback loop occurring. So again, what's happening here is we are taking the output of buffer A, running it or bringing it back via this feedback top, and then running that into the input of buffer A, creating this loop. Next up, I'm going to set the endpoint of our network over here on the right by simply adding a null and placing that to the right. This is going to be our sort of final operator in the top network. And so I'm going to call that null out. And then we're going to connect that to some additional operators in a moment to actually output that to the screen and enable interaction. So another thing that we want to make sure that we do as we're going through and making some choices about our operators is to change the pixel bit depth of our buffer A operator. Now, because we know that buffer A is going to be dealing with math specifically and is not focused on creating visible output, that tells us something about the potential data that it will output. So when we're thinking about visual information in TouchDesigner, that's going to happen in a color range or an RGBA range of 0 to 1. And by default, the pixel format that we will have chosen automatically for us is going to be 8-bit fixed RGBA, which is going to automatically put a clamp on our output range from 0 to 1. So if we're thinking about data rather than visual output, we often will need a larger range than just 0 to 1 to make the project function. And in this case, that is definitely true. So for this GLSL buffer A, I'm going to set the pixel format here from this 8-bit fixed to 32-bit float RGBA. Again, that's going to remove those fixed limits and also at the same time provide a higher resolution, so to speak, of values, color values that it can represent, which will be helpful for this sort of math that is being calculated on our mouse position. So you may have noticed we haven't yet set a resolution beyond the default 256 by 256. Don't worry about that just yet. We will be coming back and taking care of that later. So now that we've got the sort of basic structure of the top network, we can go ahead and get to work on our pixel shaders for the buffer and the image. So we're going to start over here on the left with our buffer A code. I'm going to go ahead and open this in an external code editor just to make things a little bit easier and provide some context highlighting. And so I'll bring that up and we will increase the size of things a little bit here. So we've got our code up. I'm going to bring Shader Toy back over for a moment so that we can copy the code from buffer A. So again, I'm going to just grab, everything here and hit Control C, and we'll paste it below this kind of boilerplate code so we can use this as a reference. So looking at the code from Shader Toy, we've got a function called neighbor effect, and then we've got our main image function, which corresponds to the main function found in our default TouchDesigner shader. We're doing some math. We've got a couple of situations where we are sampling from inputs, and you may also notice we have a couple of uniforms that are, in this case, specific to Shader Toy itself. So we're going to have to go through again and kind of analyze the code and figure out the portions that we're going to need to modify in order for this to function. So we'll start from the top of the shader. So I'm going to put a note to myself, first of all, that Shader Toy code pasted after this point, just to make it explicitly clear where we are starting in the code. So we've got our vec2 neighbor effect function. So this is going to output a vec2, and it's expecting ivec2 at its input. So here, everything looks good except for this iChannel0 portion of our texel fetch function. iChannel0, we might remember from Shader Toy, is how they actually define the inputs to the shader. And we do things a little bit differently in TouchDesigner. So regardless of where you're coming from, if you're looking to do texture sampling or texel fetch, etc., you're going to need to modify where the texture is actually being sampled from and use the sort of formatting that TouchDesigner expects. So in the case of TouchDesigner, we have in this demo code here, this little expression std2d inputs and then brackets with a number in the brackets. And what this is going to do is fetch the texture from the input of the GLSL top. Since we have multiple inputs, we can access those via the number in the brackets here. And if you're using one of the GLSL multi-tops, again, you can have more than just 3 inputs that the basic GLSL top has and go beyond that sort of limit. But regardless, if we want to access iChannel0, which again is the first input on Shader Toy, we want to access the first input in TouchDesigner, we can just use std2d inputs brackets 0 to do so. So what I'll do here is to select all of these lines in my code editor by hitting the holding down the Alt key and clicking them. And then replace that I channel 0 by pasting in std2d inputs 0. And that'll solve our compatibility issues in that function specifically. If we move on, we'll notice that if we have kind of taken a look at the boilerplate code, the way that the main function is declared in TouchDesigner is a little bit different than what we have in ShaderToy. So rather than having this main image function, we just have a main function, and we don't define our outs and ins within the parentheses. We actually declare the out on a separate line. So what I'll do here, I'm going to copy and paste this from our basic boilerplate code, but I do want to point out that in the case of the code we're bringing in from ShaderToy, we have this in vec2 COR, which is different from what you'll see on most ShaderToy shaders. Usually this vec2 input is going to be called frag coord or something like that. But for whatever reason, with this particular shader, it is COR. So I just want to make sure that we are on the same page, that is our usual sort of frag coord input. And when we see that within our code, that is what it is referencing. So because we're going to be removing this input, we're going to have to define it again within the code, which is fine, but something, again, we're going to have to take into consideration. So I'm going to paste in the out declaration and then the void main function declaration that we've got there. And next up, I need to set up that COR core vec2 that we just removed. And we're going to do that by defining a vec2 called COR. And this is going to pull from a reserved variable, which is how we access the frag coord variable in TouchDesigner, specifically TouchDesigner GLSL. We have to use GL_F frag coord dot XY, because we want the XY components there. And then I want to put a semicolon at the end. That will correctly set up our core vec2 so that the rest of our code functions as expected. So next up, we've got a iVec2 that is going to be accessing another uniform that is specific to ShaderToy called iResolution. This is a resolution, I believe pixel-based resolution value that is automatically provided to your code in ShaderToy. We don't have that in TouchDesigner. So if we want to access the resolution of the texture that we're generating in TouchDesigner, we can access it using another handy utility function. So again, I'm going to be setting up a vec2 called iResolution, and this is going to be accessing something called td2d infos. So u lowercase, td2d capitalized, I capitalized, lowercase, and FOS. Again, brackets, because this is looking at the inputs to the shader. And we want to access the first input here. So we're going to put 0 inside of the brackets. Then we can access the .res is going to give us the resolution. And the components of res that we want are actually ZW in this case, and that'll give us the width and the height of that texture. So that's going to be because we're accessing two components, that's going to be a vec2 already, so we should be good to go here. Now our iResolution has been set up, which again is going to allow the code after this point to function as intended. Now, if we scroll down, we can see once again we've got this I channel 0 business. So I'm going to go ahead and copy and paste my std2d inputs here again, just so that we're sampling again from the input in TouchDesigner and not having to worry about our code not functioning correctly. If we keep going, we'll see that we have a new uniform called iTime and another one called iMouse. So in the case of iTime, this is going to be something that we actually are going to input into our GLSL shader from TouchDesigner. So that'll be a variable or a uniform that we declare at the top of our code. In the case of mouse, the iMouse is actually a vec4 uniform in shader toy lingo. And this is something that provides for the first two components of that vector, the XY position of the mouse, and then the final two components of that vec4 are the left mouse button, whether or not that has been clicked or not. So we're going to have to, again, construct a vec4 called iMouse in order for this to function correctly. And we'll also have to bring in from TouchDesigner the state of our mouse. So we want the XY coordinates of the mouse as well as the state of the left mouse button, whether or not it has been clicked. So what we'll do is come back to the top, and we're going to eventually delete everything above this line that I've added here, the shader toy, code pasted after this point. So I'm going to add my uniforms up here, just again, knowing that this is going to be deleted before we finish. So first of all, I want a uniform float, which is called iTime. Again, this is another default uniform in shader toy that just provides an ever increasing time value. And then we're also going to need some uniforms for the mouse. So I'm going to need the state of the left mouse button, and I'm also going to need the position. So for the left mouse button, this can be another float, which we're going to call ULMB, U standing for uniform, just to keep things clear. And then we're going to add a vec2, which is going to be called U _ mouse POS for mouse position. And that'll allow us to input those into the shader. So I'm going to need to, as I mentioned, set up this iMouse vec4. And so I think what I'll do is to do that up here where I'm kind of defining these various variables that I need to use elsewhere in the function. So I'm going to, actually this is a vec4 iMouse equals, and then we want this to be cast as a vec4. I'm going to need the U mouse POS, and I guess I can put .xy, but it doesn't really matter. It's a vec2, and then we want the ULMB, and we can swizzle that as .xx because it's a float, and then add a semicolon at the end. So one thing I want to point out, if you're wondering where I kind of have gathered this information about the uniforms in shader toy, if you take a look at the shader toy page of the particular shader you want to look at the top, there's this little drop down that says shader inputs. And this is going to show you all the uniforms that are automatically being defined for every shader that you build. And this is why you'll see these commonly referenced within shader toy code, because, you know, it's a kind of convenience thing. They're accessible automatically. But again, we don't have these in TouchDesigner in most cases. And so what we'll have to do is to work around that by defining the variables ourselves and kind of bringing together the bits of data that we need to make the shader function correctly. So we've got a couple more things that we need to do. We have another variable here called size that has been used in a couple of different situations. And if we remember back in our shader toy code, this was something that was defined so that we could use it both here in our buffer and in our image code. And so again, I think to make things easier for ourselves in TouchDesigner land, we're going to define a uniform. And I'm going to call this uniform, this is going to be a float called size, just again, based on the terminology that they're already using in the shader. And that'll make sure that we have that accessible to our code. I noticed while I was scrolling through here, we've got another STD 2D inputs required to replace this iChannel 0 component down here. Normally you would probably go through and do like a find and replace, but I figured it would just be easier to kind of walk through step by step. And then if we keep scrolling all the way down to the bottom, one last thing that we have to do in this particular set of code is to use a function for the frag color output. If we go back to the top, in TouchDesigner, we use this TD output swizzle function when we are kind of sending our final output or setting our frag color equal to our final output for that shader. And I think this is to keep things compatible cross-platform and avoid some issues that can crop up there. So we always want to make sure that we're using that for that final step. So what I'm going to do is encapsulate this COL in parentheses and then type in TD output swizzle. So that is going to correctly be sent out of this shader as it should be. With all of that complete, I'm going to delete everything from, in my case, line 15 up, so that my uniforms are at the top of this code and none of that boilerplate code will remain in this shader code. And then I'm going to hit save and we can see what we've got in TouchDesigner. So first of all, we want to make sure over here on the right in this info, GLSL1 info dat, that we've got a successful shader compilation. So we have this little error up here, but really this is the first place we should be looking to make sure that our code doesn't have any errors in it. This little caution flag up here is actually coming up because we defined a number of uniforms within the code and we haven't yet set those up in the GLSL top itself. And so the shader is functioning without them, but we do want to define those and set up their references so that the shader does what it's supposed to. So we're going to head to the vectors page, and I'm just going to set them up based on the kind of ordering that we have here in the code. So from the top, we've got iTime, then we've got size, all caps in that case. And then we've got the two uniforms that we defined ourselves, which are going to be U underscore LMB. And finally, U mouse POS. That'll make the caution flag go away. However, we now need to provide some data, some values for these uniforms. So for iTime, we can use something like abstime.seconds in that first value box here on the left, again, to provide that ever increasing time value. For size, we're going to actually create an additional operator so that we can access this variable in our image code as well. So we will set that up now, and then we'll talk about how we can deal with the mouse interaction. So what I'm going to do first for the size parameter is to add a constant chop. Now, this might not be the way that I do this if I were to say, be building like a project for a client. I might set this up as a custom parameter or put it in Python storage or something like that. But just for the sake of simplicity and ease and sort of tweaking settings right now, we're just going to use a constant chop to set up this variable. So I want actually two things. I want a size channel, and then I want also a resolution channel, RES. We're going to be dealing with just square resolution for this particular example. So I'm going to use the width and the height are going to be the same, but if you want to, you could set up a width and a height channel instead. What I'll do then is I'm going to set the size. I believe the size was set to 12 initially in the code back on Shader Toy. I'm going to set up a null, and this will be our null settings chop. I'm going to come back to our buffer A, and I'm going to make a chop reference from this size channel by activating the viewer, left clicking on 12, clicking and dragging over to the first value box here on the left, making a chop reference. And now I've got that size variable, again, entering into the shader via that uniform we've set up. The resolution, I'm going to set to 1024 just to make our output resolution a little bit higher here. And then I'm going to come back to the constant, which remember is providing the kind of initial state of our feedback loop, and also is setting the stage for how, or at least what the resolution will be for the remainder of these operators. I'm going to make a chop reference from the res channel to the comment page to both the resolution width and the resolution height for a square texture. I can then middle mouse click and see we've got 1024 by 1024, and I will need to reset this feedback loop quickly in order to make sure that this GLSL buffer updates to that 1024 by 1024 texture. Great. So we've got those things taken care of. Now let's talk about our mouse interaction. So if you ever worked with the mouse in TouchDesigner before, you might be familiar with the mouse in DAT, or chop rather, which provides a position of your mouse on the entire screen as long as the TouchDesigner window is open. This is like a normalized, well, in this case, a normalized aspect output here, where the left is -1, the right is +1, and the top and bottom of the screen are kind of adjusted based on the aspect ratio of your particular screen. This is fine and works, and we can actually add in, like our left mouse button as we click on the screen as well. But the potential pitfall here is that we are tracking, first of all, the entire size of the screen. And that makes things a little bit complicated if we wanted to just sort of restrain our tracking to the sort of center square shape that this will output. So just for example, if I maximize this, you see our final texture is only going to be a portion of the screen, and we would then have to do a bunch of math to make sure that our kind of mouse position lines up, since we need that to be accurate to where we're sort of interacting with the shader. And so that can provide, some complication, some wrinkles, so to speak, in the process. And it actually can be easier, especially for this situation, to use one of the many panel operators in the program, as there are easily accessible normalized output values for the mouse position within the panel chop that is available. So it's going to make things a lot easier when we are wanting to use this kind of mouse interaction and sort of map that data over to our shader. So we're going to go ahead and set that up, and we'll do that over here on the right. This is going to be a panel comp, as I mentioned, and I'm going to use an op viewer as the panel that we'll be interacting with. This is going to be showcasing our null out top. So I'm going to click and drag that onto the operator viewer parameter. I'm going to turn off this interactive switch. And then for the layout, I'm once again going to use our res parameter because I want to make sure the width and the height match the actual texture. So I'm going to click and drag onto width and then click and drag onto height and hit chop reference. Now we've got a 1024 by 1024 panel. Then once I've got that set up, I'm going to add in a panel chop. And I need to tell the panel chop which panel I want it to look at. So I'm going to drag the op viewer onto the component parameter. And then we'll notice we have a ton of different channels available here, and we don't need all of them. We're going to be using this in a kind of full screen perform mode situation. And so what I'm going to use out of these many different options are the channels U and V, which are going to provide the X and Y, normalized X and Y coordinates within that panel. And then I also want the select channel, which is going to tell me when I have clicked down the left mouse button. So if I hit view on the panel and then I click with the left mouse button, we'll see here that the UV coordinates update whenever I have the left mouse button held down, and the select channel goes from 0 to 1 when I click that button. So this functions in much the same way as it does in Shader Toy, where I believe the XY mouse coordinates only update when you're left clicking with the mouse. So that has given us this super helpful normalized value for the X and the Y coordinates of our mouse. And now what we can do is to provide both our mouse position uniform and our left mouse button uniform some variables. So what I'm going to do next is to add in a null, and this is going to be our null mouse data. And then what I need to do is to make some chop references. So I'm going to click and drag from the select channel onto the first value or the first component of this uniform LMB, make a chop reference. Before we do our mouse position uniform reference, I do want to point out one thing about the way that this is defined in Shader Toy. So unlike what you might expect, we're actually provided, if we take a look at the iMouse Vec4, with pixel coordinates in Shader Toy rather than, say, normalized 0 to 1 values. So what that means for us as we're trying to convert this is that we need to take these normalized values and actually multiply them by the length and width of the texture that we're generating in order for the sort of math and everything to function correctly. So we can do that via our expression that we're going to make within these parameters here. So I'm just going to come over again to the parameter window. I'll start off by making the chop reference. I want the U to be the value in the first component there, and the V to be the second for Y. Then what I'm going to do is I need to multiply each one of these by the resolution that we've set up in our null settings. So again, if you had a separate channel for width and height, you could access them in the same way that we're going to do here. We're basically going to be making or writing a Python expression that does the same thing as a chop reference. So I'm going to multiply this by op, open and close parentheses, single quotes, null underscore settings. And then I want the second channel, or if we want to access it by name, we'll put the name res within single quotes within those brackets and hit enter. Likewise, I'm just going to copy and paste everything after the multiplication symbol here and paste that for our second value as well. So again, if you had width and height, you just change the name of the channel that you're addressing there, and it would function as intended. So with that, we've actually set everything up for our buffer. We've got all of our uniforms. Our shader has compiled successfully. We've got our feedback. We've got our pixel format set up as we need it to be. And so we can now move on to our image code. First thing I'm going to do here is to take a look and notice that our output format is 32-bit float, as it's inheriting the format of the texture coming into its input. In this case, because the GLSL image shader is just going to be being displayed on screen, as in it's not going to be doing any sort of math calculations or needing anything beyond the visible range, I'm going to go ahead and set the pixel format of this output to 8-bit fixed before we get down to business. Now what I'm going to do is open up the pixel shader code here in the external code editor again. And I'm going to do the same thing where we add in shader code pasted from Shader Toy. I'm going to go ahead and do the same thing where we add a little note to ourselves. I'm going to head back to Shader Toy, and I will copy and paste everything in this portion of the code as well. This one's going to be a little bit more straightforward because we don't have quite as much kind of custom uniform declaration to deal with, but Nonetheless, we have some things to take care of. So as I'm kind of looking through the code, I'm going to go back to the top. We've got a bunch of different functions that are doing some math, doing math to generate the geometry that we see. We've got some mapping, some normal generation, et cetera, et cetera. And then finally, we have our main function. So everything before the main function, besides, let's see, I think everything before the main function, except for this size variable, is going to function as expected. So we definitely need to, just like in the other buffer, we need to define a uniform called size. We need to go ahead and swap out our iChannel 0 here with the std2d inputs. And then let me see if we've got anything else that needs to be added. And then we'll need to do our td output swizzle for the final output. So starting from the top, let's go ahead and add in our uniform called size. So we've got, after the note here from David, we've got uniform float size semicolon. I'm going to go ahead and copy the std2d inputs portion from the kind of boilerplate code, head back down to our main image function, which we do need to change to main function. I don't want to forget that. I'm going to paste this over the iChannel 0 in the code. We need to, let's just copy and paste this from the top. So I'm going to grab the output, frag color, void main function declaration, head back down to main image, paste. That's good. We've got size, we've got std2d inputs, size again. Okay, then for frag color, we need again to encapsulate everything inside of, or everything that's already here inside of parentheses, and then add td output swizzle to the beginning. And with that, we can go back to the top and delete our boilerplate code. Now is also a good time to mention that the final version of the code will be available via a link in the description. So if this has gone too quickly or you need to reference it, if you're having some issues, you can grab that and compare and contrast to what you've got in TouchDesigner yourself. All right, so with that complete, I'm going to come back to the top. I'm going to delete everything that came with it by default. I'm going to hit save, head back to TouchDesigner. We've got a compile issue. You see, I did miss something. So this is why it's important to check the compilation results even before we're looking up here at the kind of warnings that come with the GLSL top. So what I need to do is to open up my code again. And what that error was talking about is the core input that was defined in the code that we need to set up manually, which I forgot about. So again, just like in our last code, we're going to set up vec2 core equals gl frag chord dot xy semicolon and hit save. And then if we go back, now we should have a successful compilation. Now here, we have not yet set up our size uniform, so we're getting a warning about that. So what I can do is, again, click on the GLSL top. I'm going to come to vectors. I'm going to set up one called size uppercase, and then I want to make a chop reference from my size chop channel to the value parameter. And with that, we can actually see that we have a bunch of cubes, which is great. So what we can do then, just to kind of test this out, is open up our op viewer, and we should be able to then click and drag, and it should function just like it does on Shader Toy, which is amazing. So we can then come back here, because we've set these up as chop channels and, increase our size to something like 16. And then again, right click on the op viewer and hit view. Now we have a little bit larger cubes. We could keep increasing that if we want to. But for all intents and purposes, the shader has been translated to function in TouchDesigner. One last thing I want to showcase is the ability to customize the shader, whatever it may be, by adding in some additional uniforms of your own, which would then let you use some of the built-in TouchDesigner operators to control different aspects of the shader. So for example, we've got this particular case where we've got these blue cubes that we're generating. And let's say we wanted to, for whatever reason, control the color of those cubes, maybe interactively or just with a sort of static setting like we've got up top. All I would have to do is to come into the GLSL pixel shader code, which I'm going to open up again, and come to the top here. And after my uniform float size, I could put in something like a uniform vec3 color, and then utilize this within my code. So once I've defined the uniform, I can come down to the portion of the code where the color is defined, which is right here. And what I might do so I can come back to the default state is to comment this out and then paste in a second copy of that code. I will then access my color uniform that I've set up and replace that vec3 portion of the code with color. Then I can hit save and head back to TouchDesigner. And again, we've got a little warning flag because we haven't yet assigned that uniform. I could then add another vector uniform by hitting the plus sign here and type in color, which is by default set to 111 for the RGB channels, meaning that we've got now white cubes instead. But I could always come back in here and adjust my color parameters so that I can end up with red cubes if I want to, or any other color in between. And just like the other parameters that we've looked at, we can, of course, control these with chops, control coming from the mouse, or any number of other generative options as well. So it doesn't always have to be that, we're working within the GLSL code itself to generate some kind of particular animation or control over a parameter in TouchDesigner, because we've got all of these, handy chops available in this way of sending that data into our shader. We can very easily set this up and start experimenting and iterating in a very fast manner. So anyway, that is it for this particular tutorial. I hope you have enjoyed putting this together and learned something about translating, adapting shaders to be able to be used in TouchDesigner. I want to, of course, give a shout out to Dave Hoskins for doing the programming, the heavy lifting to really make such a cool and interesting shader, and for making it available via the Creative Commons license. I, of course, will have this linked in the description below. Definitely check it out, as well as Dave's other shaders. And if you're looking for a little bit more information, maybe some more advanced info about shader programming in TouchDesigner, I'll also provide this link in the description for the Write a GLSL top page in the documentation, which has a ton of great info about the specifics of shader programming in TouchDesigner, the kind of terminology that is used within the program specifically that, is unique to TouchDesigner. And that is a very helpful resource as you start diving down this rabbit hole. So anyway, with that, hope you've enjoyed putting this together. Looking forward to seeing you in the next video. Thanks so much for watching.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner and Creative Tech Pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and Immersive content.